Hello, students! Today we are going to look at a very important topic.
Let's start with a puzzle from the chemistry lab. You might have seen this yourself. You have a light blue solution of a copper salt, and when you add ammonia, it suddenly turns into this beautiful, deep royal blue. Why does this happen?
The secret behind this color change, and many other fascinating phenomena in chemistry and even in our own bodies, is a special type of chemical bond. Today, we're going to demystify the topic of bonding in coordination compounds.
Okay, let's dive into this. At the most basic level, it's a story of giving and receiving. We have one species, called a ligand, which has a pair of electrons it is ready to donate, and we have a metal atom, which has empty space or an empty orbital ready to accept that pair.
Here's the simple way to imagine it. Think of the metal atom as someone with empty hands just waiting. The ligands are like friends coming over, each carrying a gift, and that gift is a lone pair of electrons.
Now, what's really happening at the molecular level? The ligand places its gift, the electron pair, into one of the metal's empty hands. This forms a proper chemical bond called a coordinate covalent bond. It's a strong connection that holds the ligand and metal together. For your exams, this is the precise definition. So, the crucial point is that the ligand is the electron donor, and the metal is the electron acceptor.
Now, a common point of confusion. Do not mix this up with an ionic bond. In an ionic bond, an electron is completely transferred from one atom to another. Here, in a coordinate bond, the electron pair is shared. It is a type of covalent bond.
And this brilliantly illustrates the idea with a simple analogy: the handshake. The ligand extends its hand, the lone pair. The metal offers its empty hand, the empty orbital. They clasp, and a bond is formed. It's a mutual, shared connection.
So, you might ask, why do we need a whole new bonding theory for this? Why doesn't simple ionic bonding, positive attracts negative, explain this?
Let's move to this slide and see how this builds our understanding. This concept is essential because it explains how a neutral molecule, like ammonia, can form a very stable bond with a positively charged copper ion. Simple attraction of charges doesn't work here. It explains that the only requirement for a ligand is to have a lone pair to donate.
Now, let's build a mental movie of this process. We will watch the formation of a complex between nickel 2+ and 4 ammonia molecules. Imagine a central sphere, our nickel ion. It has these empty slots around it, ready to accept electrons.
Now, an ammonia molecule drifts closer. Notice the glowing dot on the nitrogen atom? That's the lone pair, the gift it's carrying.
Watch closely. The lone pair fits perfectly into one of the nickel's empty slots. Instantly, a connection forms, locking the ammonia molecule in place. That's our coordinate bond.
This happens again and again and again, until 4 ammonia molecules have docked. They don't just cluster randomly, they arrange themselves into a precise geometric shape. The complex is now formed and stable.
So, why does this matter to you? First, it solves our starting puzzle. The deep blue color appears because new, strong coordinate bonds form between copper and ammonia. Second, this is happening inside you right now. Hemoglobin, the protein in your blood, uses a coordinate bond to grab oxygen in your lungs and carry it to your cells. And finally, it resolves that counterintuitive idea. Neutral molecules can and do bond to positive ions through this mechanism.
So, for your exams, let's recap the 3 most important things. The core idea: ligand donates, metal accepts, a shared bond forms. The simple analogy: the handshake. And the most powerful real-world example: hemoglobin carrying oxygen.
I want to leave you with this thought. Don't get overwhelmed by all the details. If you can just remember that simple core idea, the mental picture of the bond forming, and the hemoglobin example, I promise you, this topic will feel much, much easier.
And that makes you wonder, doesn't it? If this one type of bond is so fundamental to something as basic as breathing, what other incredible secrets of biology and medicine are waiting to be understood through coordination chemistry? Thank you for watching.